In Unit 12, Section 2, we're talking about the multiplication principle, but we're actually talking about making a tree diagram and the multiplication principle. So a tree diagram is one way to count the number of possibilities that you have when you're doing something. So the directions say to make a tree diagram. There we go. Make a tree diagram to find all the possible choices. So the first one says choose a sedan, truck, SUV, or minivan in red, blue, or green. So we have two different things we have to figure out. Figure out what kind of car and then what color it's in. So to make a tree diagram, you're going to start by listing out all the first ones. So that would be a sedan, a truck, an SUV, or a minivan. So you just list out all of the first ones. Then your tree actually grows left to right, which isn't like a normal tree, but you're going to draw your branches off of that. So if I have a sedan, I could have a red sedan, a blue sedan, or a green sedan. If I have a truck, I could have a red truck, a blue truck, or a green truck. If I have an SUV, red, blue, or green. If I have a minivan, red, blue, or green. So my number of possibilities are however many I have over here on the far right. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 possibilities from my 4 types of cars or my 4 types of automobiles and the 3 colors that it could come in. So looking at example 2, it says choose turkey or ham. So 2 types of meat with 3 types of bread. So we would put our 2 types of meat, that's not how you spell turkey, turkey and ham, and then our 3 types of bread. So white, wheat, or rye. White, wheat, or rye. And then figure out how many possibilities we have. We just count over here. 1, 2, 3, 4, 5, 6. We have 6 possibilities. So that's one way to figure out how many possibilities you have. A much quicker way that does not involve drawing anything out is to use the multiplication principle. So here's the definition out of a book. Out of the book, it says the multiplication principle. If one event can occur in m ways, and for each of these ways, a second event can occur in n ways, the number of ways that the 2 events can occur together is m times n. The multiplication principle can be extended to 3 or more events. So it says find all the possible solutions. It says that a menu has 3 choices for salad, 4 main dishes, and 2 desserts. How many different meals are possible if you select a salad, a main dish, and a dessert? So all the multiplication principle tells us is that we're going to multiply all the choices. So we have 3 choices for salad, we have 4 for a main dish, and 2 for a dessert. So we multiply those together, get 24 meals. Now, if we did a tree diagram, it'd give us the exact same answer, but then obviously this is a little bit quicker. For number 2, it gets a little bit trickier because you have to figure out a couple things. It says you are choosing a computer password. The password has 3 lowercase letters followed by 2 digits. Okay, so there are 26 letters in the alphabet, and when we say digits, there's 10 digits because we're talking 0 through 9. So for A, it says how many passwords are possible if there are no restrictions. No restrictions means that I can use the same letter multiple times. I can use the same digit multiple times. So to figure this out, we have 26 choices for our first letter, 26 choices for our second letter, and 26 choices for our third letter. Then we have 10 choices for our first digit and 10 choices for our second digit. When you multiply all of those together, and I just expect you to use the calculator, you get 1,757,600 possible choices. For B, it says how many passwords are possible if no letter or digit can be repeated. So this is where it gets a little bit more complicated. But when I have my first letter, I still have 26 choices. Here's the thing. For my second letter, I only have 25 choices because I can't repeat. And then for my third letter, I have 24 choices because I can't repeat either of the first 2. For my first digit, I have all 10 choices. For my second digit, I only have 9 choices. Then when you multiply all those together in the calculator, you get 1,100,000 404,000 choices. Now, at the bottom, we're looking at finding a probability using the multiplication principle. So it says for the following questions, you have a 6-sided number cube, which is not shown, and then you have the spinner that's shown. So 6 sides on the cube, 4 spaces on the spinner. It says you spin the spinner 2 times, find the probability that the spinner stops on 1, then 2. So what we have to say is when we spin it the first time, there's 4 possible choices. When we spin it the second time, there's 4 possible choices. So we have 16 possible choices. And then the probability to get the one number that I want on the first one and the one number I want on the second one is going to be 1 out of 16. For number 2, it says you roll the number cube 2 times. Find the probability that you roll a 1, then a 2. So the only difference here is when we roll the number cube, we have 6 possible choices the first time and 6 the second time. So 36 total choices. So then our probability would be 1 over 36. So on the front page of your notes, but on the back side of the video, or maybe it might be the back side on your notes, there's one more question that goes with this. It says you spin the spinner once and roll the number cube once. Find the probability the spinner stops on the same number that you roll with the number cube. So I spin my spinner, there's 6 possibilities. I roll my number cube, I spin my spinner, there's 4 possibilities. I roll my number cube, there's 6 possibilities. So that's 24 total possibilities. So my probability would be 1 over 24. All right, so for the review problems, you have some proportions to solve. Remember, you're just going to cross multiply and divide. Show those review problems in the rest of your notes to your teacher before you take the Unit 12 Section 2 check-in.